Hi there and welcome to a brief video on showing an example of tracing a path through the UCS system. Now there's a number of excellent blog posts on this out there, but I wanted to just show you some useful UCS CLI commands. I've been asked a number of times by customers now what those CLI commands would be and how can you get just a little bit more information than you would normally get from the UCS GUI. So let's get straight into it. Here on the screen in front of you now is just a very kind of brief slide here just to make sure that we're all familiar with the terminology and where those paths and decisions need to be made. So Fabric Interconnects, clearly they're the brains of the UCS system, central point of management, central point of configuration. This dotted line here shows the demarcation between the Fabric Interconnects and the physical server blade chassis themselves. So the I/O modules, or the FEXs as they're also referred to within UCS, are an extension of the fabric from the Fabric Interconnects into the chassis. So these replace the switches you would see in a traditional blade chassis itself. Then we have the server and clearly the adapter and everything else, and then there's the northbound switches which the Fabric Interconnects will connect to. Arrows on the screen reference the egress out of the system and ingress into the system. So if we start with the egress side of things, clearly the first decision which needs to be made is which PCI interface will the operating system use to transport the traffic out of the system, and this will be down to typically down to the operating system's routing table, etc. From a hardware perspective, we'll need to know which CNA port. CNA is Converged Network Adapter, and in this instance we're using the Cisco VIC card, which is the virtual interface card. So we need to determine which port this will leave the server on. And this will be down to the configuration itself within UCS Manager, whether Fabric failover is enabled or not. And again, I won't touch on that in any detail. If you have created vETH ports, which will appear as ETH ports to the operating system itself, if they're pinned to a particular fabric, etc., that will determine which way out of the system we go. Let's assume it takes the left-hand side here. When we get to the I/O module will have a Fabric port, which is here. Which port do we then leave the I/O module to the Fabric Interconnect on? If that's a port channel, then clearly there'll be a hashing mechanism that happens here to determine which link within the port channel we will select for that traffic flow. When we reach the Fabric Interconnects potentially can switch the traffic locally if they are aware of the MAC address on its southbound server facing ports here, or if it doesn't know, then it will need to determine which uplink port channel it will send the traffic out to the northbound network on, and again, if it is a port channel, then which link within that port channel it will use. These don't have to be port channels, but in this example they could be virtual, they could be VPC is a good example. Or they could just be standard single links, but in this instance we've got a port channel. So that's the steps, just a quick summary of some of the steps you go through on egress. Then clearly on ingress we have a series of steps as well. So the northbound switch itself will determine which link it needs to send the traffic towards UCS on. When UCS receives that traffic, it needs to determine whether or not it's going to allow that frame inbound. If it's in its default end host mode, then there's a series of loop prevention mechanisms that we have in place, such as a deja vu check and an RPF check, which will kick in. I won't go into any detail on these here. This is meant as a brief video, but maybe that will be subject of a future video. Or there are a whole array of good blog posts out there which talk about end host mode versus switch mode and everything else. The Fabric Interconnect will then need to determine which Fabric port it needs to send that traffic down on, and again, if that's a port channel, there'll be a hashing mechanism which that happens on. When the I/O module needs to make sure the traffic is going to the right server bay, so there will be some VN tagging going on here. Again, I won't touch on that in any detail, but the traffic will need to be pushed to the right server, and then again the operating system, well, the frame will then eventually enter the operating system. So there's a series of decisions which need to be made egress and ingress into the system. So at this point, I think we should hit the CLI and we'll have a look at an example of tracing that flow through that system itself. One thing to bear in mind, actually, just before we do that, is some of the again acronyms which are provided to the system, and again these will be very useful when you are tracing that flow. So the first one here is the VIF, the virtual interface, and will reference a virtual Ethernet port or a virtual fiber channel port. Again, there's some caveats around that with fabric failover. There's actually another interface called a LIF, a logical interface, but we won't touch on that here because we don't have fabric failover itself configured. We'll then have a UIF, which is an adapter uplink interface. Each adapter's got two physical uplinks, one to each I/O module, or one which will face out towards each of those I/O modules. And again, if it's the 1200 series VIC cards, then as you can see there, we've got port channels which are created from the adapter to the I/O modules themselves. You will then also have the HIF, the host interface itself. Now, depending on the I/O module model you have, determines how many host interface ports are available to the system. So if it's a 2100 series, there's 8 internal ports, one for each of the blades. If it's a 2200 series, then we have massively increased that. So 2204 will have 16 internal ports, which provides 2 to each of the blades, and a 2208 has 32 internal ports, which provides 4 to each of the blades. We can get huge amounts of bandwidth to each of those blades themselves. There's a couple of great, again, blog posts out there which talk about that in detail. TJ's got a very, very good blog post which talks about port channels and bandwidth and everything else within that. We have the network interface. These are the ports the IOM defines as connecting to the Fabric Interconnect. The SIF, the SIF in this instance, is the server interface. And again, the server interface is just exactly the same, but on the FI side, what connects to the IOMs themselves. And then we'll have an uplink interface. And what's really useful when you are tracing that flow, and I can't recommend it enough, is to make sure you've got a little table with you so you do map this out, and it all makes a great deal of sense. So if we have a look at the CLI, so the first thing we're going to do is we're going to have a look at an example of a service profile, and we're going to pick an interface, and then we'll trace that through. So something we can do here is we'll do a show service profile status. Show service profile status will show you all of the service profiles and the templates that are currently created on the system. If they are assigned and associated, they'll show you which server number you are currently assigned to. So in this instance, ESX2 is assigned to server 13, ESX1 is assigned to server 1/1. It shows this is on and this is operational state OK. So this is probably a good example to use for tracing that path. So what we'll have here, we'll do a show service profile circuit server, and we'll go with 1/1. So what you could have done instead of 1/1 there is you could have used the name as well. It gives you exactly the same information. But what you can see here is that this is the virtual interface. So we have only 2 Ethernet interfaces configured here. This is purely for simplicity for the sake of the video. But if you had multiple, then you would see them all listed here, including the virtual HBAs as well. So we'll use this as an example. Virtual interface 866 is ETH0. We don't have fabric failover currently configured. If we did, we would see something here under the protected state. You'd see protective and active, and you'd see passive and backup in these roles. Because we don't, we know that there's no fabric failover configured there. Again, I won't go into detail on fabric failover as a technology. We can go through that in a future post. We can see from an operational pinning perspective that we are on 117, and we'll come back to that. But that does give you a view of the border interface that it's using to leave UCS. But for the sake of this, virtual interface 866 is ETH0. So we'll put this in here. 866 is what we're looking at. Next thing we're looking for is the uplink interface from the adapter. Now this is a slightly different example than maybe what you would be used to on a half-width blade. UCS has half-width and full-width blades. We're using a full-width blade here, and there's 2 adapters in them. So I've already done a little bit of work in the background to know which adapter I'm connected to. But these are the steps you would then go through. So from the UCS CLI, you can connect directly to the adapter. So that's server 1 in chassis 1, and that's adapter 2. To connect, and we need to attach to MCP, master control program. And from there, if we input the command VNIC, what we'll see here is we will see that 866 is on interface 0. So it's 0 and 1 for each of the adapters. As I mentioned, there's two adapters, adapter 1 and adapter 2. Because we have two adapters in this particular blade, we currently have the interface itself, 866, is on uplink interface 0 on adapter 2. The next thing to do is to have a look at the host interfaces themselves. So in order to have a look at the host interface that it's connected to, we need to connect to the I/O module. So we need to exit this. Now I'm connected to I/O module 1, I/O module 1 in chassis 1. As you can see, this is what I mentioned earlier with regard to IOM and FEX being kind of interchangeable terminology here. What we will issue here from a command perspective is a show platform software. Now at this point, there is the next keyword may not make a great deal of sense unless you understand the ASIC names from a UCS perspective. So if you have a 2100 series I/O module, then the ASIC name which is used is called Redwood. If you have a 2200 series, which is what we have here, then it's called Woodside. And this is really one of the only instances you need to know any of the ASIC names, just because the show commands in this instance reference that ASIC name. So show platform software Woodside STS. Now what this gives you here is it gives you a view of the blades, the FEX port they're connected to, the host interface port and the network interface port. And as we mentioned already, the network interface are the ports that connect directly from the IOM up to the FI, and the host interface are the internal interfaces which connect to the blades. And as we mentioned again previously, depending on the model of the I/O module depends on how many host interfaces you have available, and again how much bandwidth would be made available to those blades. Now if you have a look at the legend in the top left hand corner, you can see that if there is a dash, it's up, if it's a colon, it's down. Now we know we're looking at blade 1. We know that blade 1 is here on the right hand side. We can see this number here references the FEX port. So in this instance it's FEX port 1/1/1. We can see it's connected to host interface 31. And at this point we don't know yet what the network interface is. So what we'll do is we'll input these onto the, so it's 31, host interface 31. So hopefully this is making sense. We are using blade 1, we know we're using blade 1 because that's the command we used previously. We had the service profile ESX, which was on ESX1, which was on blade, so chassis 1, blade 1. You can see blade 1 is currently connected only on one of these ports, which is FEX port 1, host interface 31. And what we need to do now is we need to understand which port, which network interface is connected to. And for that, there's a really handy command which we can use. So if I exit this, there is a show system internal. Oh no, I need to connect to NXOS first. Show system internal FEX info SAT port Ethernet. Now what I've done here is I've input the FEX port, which we've learned from the previous command. We've learned that blade 1 is connected to FEX port 1, which is connected to host interface 31. So it's 1/1/1 in this instance. That's the I/O module in chassis 1. So we can see here that 1/1/1, the fabric interface, which we'll come back to, is 1/3, but the network, you can see host interface 31 is connected to network interface 0. So if we put this in here, network interface 0, fabric interface 1/3, this references this port. So we can see that is ETH1/, in fact let's put 1/3. So this is a really useful command. Now, this what this does show you as well is, if you haven't already checked and this is a system you've not seen before, that we're using static pinning here rather than port channeling. And again, I urge you to have a look at the blog posts on that and what that means. But essentially, from a static pinning perspective, the blade slots will be statically pinned to one of the network interface links which are active. If it's a port channel, that clearly is a port channel. In this instance, there'll be a hashing mechanism which is used in order to determine which link in that port channel from the IOM up to the FI is used for that particular flow. If that was the case, and you did have that, you could use a command which would be show port channel load balance forwarding path interface port channel. Then you'd input the port channel number. I can't do it here because we're not doing it, but you'd input the port channel number, then a VLAN and a VLAN number, the keyword source IP, and then an IP address, and then the keyword destination IP and the destination IP address. And what that would do then, it would show you which link in the port channel it would pick from a hashing perspective based on the parameters that you've input. So again, a very, very useful command to then have a look at which of those links would be used within a port channel. And that would work for internal port channels as well as external port channels. Okay. So another command which we can use just to make sure that the information we've seen in that previous command there does make sense, we can do show FEX detail, and we can see that from a FEX port perspective we know we're talking about 1/1/1 because that's what we've just seen previously, and we can see that it's connected to 1/3, which shows that the information we've just seen is indeed accurate. Again, what this also shows is, as well, is from a pinning mode perspective, it's static rather than port channeled. Again, if it was port channeled, we would see on the previous command, if we just scroll back up, here on this fabric interface, I'd expect to see a port channel number. There would be a port channel and there would probably be a 4-digit number starting with 1, because that's what the internal port channels are typically use. Okay, so now what we should have is all of the information for the internal ports, and now what we want to have a look is the uplink port. So the uplink port from the fabric interconnect up to the switches. So for this we can use the command show border, no, show pinning border interfaces. And we can, if this was a production system, you would typically see a lot more interfaces in this list. But for me, I actually only have in this instance one uplink coming out of this lab system, and it's Ethernet 1/17. And if I have a look here, I can see that from a vEth perspective, 866, which is my virtual interface number here, is actually pinned to ETH/1/17. So I know now 1/17, I can see I've now got a good view of all the way out of the system the physical path that the link to that server should be taking. What you can also do is a good old Cisco command, show CDP neighbor, and that would then show you what I can see on that port. So I can see that on 1/17 I'm connected in this instance to a Nexus 3000 switch, which also then the remote port is 1/16. So I also have a view of not only all the way out of the system, but also what link I can see on the other end of the system as well. If that's a Cisco switch, then we can use that command on that end. So that should give you a very good view then of traffic all the way out of the system. So there's clearly a whole raft of commands we can use here. We can use, in fact, as another example, one of the things I've seen customers do before is if we connect to the IOM again. This is a useful command. This will show you the network interface and host interfaces in use, and it's a point-in-time snapshot of the traffic flows through the system. Something to look out for is this column on the right-hand side. If there's any errored packets or frames, or any errored frames, you'd see a star there. So again, it's useful for troubleshooting purposes. Now, again, a whole raft of commands which we can look at. You can use this command and you can use variants of this command to then have a look at individual network interface and host interfaces and get very detailed counters on all of the traffic flows and the various where we're seeing unicast, broadcast, all sorts of different information that you can see on those interfaces. But for now, I think this is a good summary of kind of how to look through a system, how to trace a physical a path through the system, and hopefully that all makes sense, and I hope that was useful. So with that, I'll leave it there. Thank you very much for watching.